Okay, and now we're back to finishing off our review worksheet for Unit 8. We're going to do number 44, 45, and 46, and number 50. So in 44, 45, and 46, we're going to write in exponential form, and then we're going to solve for x. So the strategy is, if anything is in radical form, like the radical of 16 to the third, the first thing you want to do is you want to rewrite this in exponential form. That would become 16 to the 3 over 2 exponent times 16 to the 10 over 2 exponent, and that would be equal to 16 to the x over 2 exponent. Okay, so always whenever you're solving for x, if you have parts of the equation in radical form, move them into exponential form. Okay, then remember what we want is we want a 1-to-1 base ratio. So in other words, if you notice on the right side of the equal sign, we only have one base of 16. But on the left, we have two bases of 16. So what we're going to do is we're going to combine these two bases of 16 together by using the product rule, which says that we multiply, if we're multiplying, we add the exponents together in order to simplify it. So this would become, when I work it out, it would become 16 to the power of 13 over 2 is equal to 16 to the power of x over 2. Now, once you get one base on each side of the equal sign, and if they're the same base, the bases will cancel each other out, and then you write exactly what is left over, and then you use that equation, which would be 13 over 2 is equal to x over 2, to solve for x. Okay? In this problem, because both fraction has the same denominator of 2, the 2's would cancel each other out, and your solution would be x is equal to 13 to number 44. Okay, moving on to 45, we're going to do the same concept. You notice the first part of the equation is in radical form, so my strategy is move everything into exponential form. This would become 16 to the 7/3 power. Times, I'm going to move this also, whoops, a 64, excuse me, not a 16. I'm going to move this into exponential form too, which would become a 64 also to the 7/3 power. And then the right side of the equation, it's already in exponential form, so I don't have to change it. Okay, so that's always my first step in my strategy. Then I need to rewrite my equation so I have a 1-to-1 base ratio. Notice on the right side of the equation I have one base, 64, but here I have two bases of 64. So I'm going to use the product rule, which says merge the bases together, don't multiply them, but add the exponents to simplify. So you end up with one base. When I do this, I'm going to get 64 to the power of 14 over 3 is equal to 64 to the power, or the exponent of x over 3. Now, when you have 1-to-1 base ratio and the bases are the same, those bases will eliminate each other, and then your equation that you're going to use to solve for x is what's left. 14 over 3, I have an equal sign, and x over 3. Okay, just like in the previous problem, when I get to this point in my equation, if the denominators are the same, you could just cancel them out, and you have your solution without actually having to do any algebra. X is equal to 14. Okay, 46, same idea as 44 and 45, but the difference is I'm going to have to use a different rule because I'm dividing. So I rewrite the problem, keeping everything that's in exponential form, changing this denominator part into exponential form, so that would become x to the 4 over 6 power equals x to the 8 over 6 power. Okay? Now I have to rewrite my problem. So I'm just going to rewrite it over here. I have an equal sign. My right side of my equation has only one base, and that's what I want because I want one base on each side. And then I'm going to use the quotient rule to rewrite my left side of my equation as one base. So I merge the 8's together into a base of 8, and then the quotient rule says when you do that, you subtract the exponents. So I'm going to go 4 over 2 minus 3 over 6. Okay, I need to simplify this. I can't subtract until I have a common denominator. So I'm going to have to change that 2 into a 3. So I'm going to have to multiply by 3. So this would become 9 over 6 minus 4 over 6. So that the left side of my equation will become 8 to the 5/6 power. That's going to be equal to 8 to the x over 6 power. Notice now I have a 1-to-1 base ratio. That means just simply there's one base on each side of the equation. If they're the same, they eliminate each other. You write whatever you have left, and then you're going to use that equation in order to solve for x in your solution. Once again, I get to this point. If the denominators are the same, they cancel each other out, and you don't have to do any algebra to solve, so we would get x is equal to 5. Okay? All right, so the last problems that you had to do was number 50. And number 50, the instruction said, complete the table, write an equivalent expression to the following in the form a to the m power times a to the n and a to the n to the m power. So what we're doing is, if you notice, there's 3 rows of this problem, and the first row says a to the 14th. So what we're doing is we're just coming up with an equation, and we're saying to ourselves, okay, I have to put an a, and then I have to have some power, and I'm going to multiply it by an a, and that's going to be to some power, and whatever numbers I put in the square and in the triangle, when I follow the multiplication or the product rule, I have to get a to the 14th power. Okay, well, the rule says that in order to simplify this, you would add the exponents together. So really what this problem is saying is think of 2 numbers that when you add them together, it multiplies or it adds to make 14. Okay, well, we got a lot. We have an infinite number of choices. 0 and 14, 1 and 13, 2 and 12. 3 and 11, 4 and 10, okay? I've got a lot of choices right here, all right? But I got to go over here. And this problem is saying that when you take a and you raise it to the same power that whatever number you're going to put here, and then you make m the same number that of whatever you're going to put right there, that is going to have to be also equal to a to the 14th power. Now remember, this rule, we call this the power rule, and this is saying that you're going to multiply the 2 numbers together. And whatever 2 numbers you pick, it has to equal out to a to the 14th. So the question is, what 2 numbers, when I add them together, make 14, but at the same time, when I multiply them together, it's going to be equal to 14. Okay? Well, what we can do here is that I could put any 2 numbers I want here. 7 and 7. 7 or 8 and 6, okay? And then whatever numbers I put here, they have to multiply to make 14. All right, so for this answer, there's many different answers that we could have, but I'm going to choose a, and I'm going to make it to the 6 times a to the 8. Notice 6 plus 8 is equal to 14. And then over here, I'm going to just have 2 numbers that multiply. So I'm going to make n 2, and then I have to multiply it to make 14. So I'm going to put a 7 right there. Okay? So you guys, that's what I'm doing. Same idea in the second row. I'm coming up with 2 numbers. And when I use the product rule, it has to be equal to x to the negative 12th power. I have many choices for this. I'm going to choose negative 2 and negative 10. Negative 2 plus negative 10 is negative 12. That would work. And when I put it into this rule, I need to come up with an exponent that when I multiply it by another exponent, it's going to be equal to x to the negative 2nd power, or 12th power, so maybe 6 and negative 2. 6 times negative 2 is negative 12. Okay, last one, number The last row, I have to use the product rule, so I have to come up with two numbers that when I use the product rule, whatever numbers I put for the exponents, they have to add to make 20. Okay? So we could go 18 and 2. Why does that work? Because 18 plus 2 is equal to 20. And then using the power rule, same idea. I have a p, and then I'm going to have an exponent and an exponent. And when I multiply them together, they also, whatever those numbers I picked, have to multiply to make 20. 5 and 4 would work. 5 times 4 is 20.